Hello everyone. So this is a question from JEE Advanced 2026 paper 2. Correct statements about the compounds P, Q and R is okay. So xenon reacts with fluorine in 1 is to 5 ratio. These are the conditions to give us P. Okay. P combines with O2F2 at 143 Kelvin to give us Q, an oxygen gas. Q combines with water to undergo complete hydrolysis to give us R and HF. Okay. So these are some of the options. The chapters involved is P block and chemical bonding. Okay. So before we look into the options, it is important to know that xenon is a noble gas. Yes. So xenon is a noble gas, but it still form compounds because its large size results in a weaker hold on its outermost electron. Xenon has a very big size, and the outermost electron, because of this big size, the hold of this nucleus on the outermost electron is weak. Okay. And also there are lot of inner electrons present, due to which there is large shielding of this particular outermost electron by the inner electrons, due to which this guy cannot experience the full power of this nucleus. Okay. Therefore the pull with which the nucleus pulls the outermost electron is not very high, due to which highly electronegative elements like fluorine, oxygen, these guys, they will pull the outermost electron or attract xenon's electron away to form chemical bonds. Okay. So therefore xenon does form compounds in spite of it being a noble gas. Okay. When xenon combines with fluorine, so xenon combines with fluorine, when xenon combines with fluorine in a 1 is to 5 ratio, this is important. Okay, this ratio is the experimentally determined molar ratio to get the best yield of XeF4. Okay, this is the experimentally determined molar ratio of, obviously, xenon is to fluorine to get best yield of XeF4. Okay, so with respect to reactions, we can write xenon plus F2. The conditions are 873 Kelvin and 7 bar will give us XeF4 in the solid state. When you balance this, you will have a 2. Okay, so the balanced chemical ratio is 1 is to 2. You can see here 1 is to 2 is the balanced molar ratio, and the experimental ratio to get the best yield of XeF4 is 1 is to 5. Okay, so therefore obviously we have to take fluorine in excess so that we can get XeF4. Okay, so therefore our P is this guy XeF4, which is also known as xenon tetrafluoride. Okay, cool. Now when XeF4 when reacts with O2F2, okay, XeF4 when it will react with O2F2, O2F2 is also known as dioxygen difluoride. Okay, at a temperature of obviously 143 Kelvin, we get XeF6. The product is XeF6, and XeF6 is known as xenon hexafluoride and obviously oxygen. So with respect to reactions, we can write XeF4 plus O2F2, temperature 143 Kelvin, will give us XeF6 plus O2. Okay, therefore Q is our XeF6. And when XeF6, that is xenon hexafluoride, undergoes complete hydrolysis, it gives us XeO3. Okay, when this guy undergoes complete hydrolysis, we get XeO3. Okay, with respect to reaction, we can write it in this fashion: XeF6 plus H2O will give us XeO3, and XeO3 is known as xenon trioxide plus HF. When you balance them, you will have a 6 here and you will have a 3 here. So this is also known as xenon trioxide. Therefore, R is XeO3. Okay. So now let's look at the options one by one. The first option A says that P, that is, XeF4, has two lone pairs of electron on central atom. Okay. So to check this, let's draw XeF4's Lewis dot structure. Okay, to draw the Lewis dot structure, count the total number of valence electrons and make sure to distribute minimum 2 electrons between any two atoms. Okay, so the total number of valence electron is going to be 8 from xenon plus 7 from each fluorine, and there are total 4 fluorine, so therefore it's going to be 36. So we have to distribute 36 electron. So draw xenon, fluorine, 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 fluorine. So I'm representing 2 electrons between xenon and fluorine as a single bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there are total 32 electrons here. Okay. Obviously, extra 4 electrons, because there are total 36 electron to be distributed. So the extra 4 electron are present as lone pairs on xenon. Okay. So therefore, the correct electron dot structure of XeF4 is going to be xenon, fluorine, 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 and two lone pairs on xenon. Okay. So therefore, XeF4 does have two lone pairs of electron on the central atom. Okay. So therefore, statement A is a correct statement. This is a correct statement. Okay. So, XeF4, that is this guy, is an example of a hypervalent molecule, because the central atom has more than 8 valence electron: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. Let's go to the B option. B option says that Q, that is, XeF6, has perfect octahedral geometry. Okay, so to achieve a perfect or a regular octahedral geometry, the central atom must have 6 bond pairs and 0 lone pairs. That's the requirement. Okay, for perfect octahedral geometry, central atom should have 6 bond pairs and 0 lone pairs. Okay, let's check whether it's the case for XeF6 or not. So obviously the total number of valence electron is going to be 8 from xenon plus 7 from fluorine. There are total 6 fluorine, so it's going to be 50 valence electron. And let's draw the electron dot structure. So xenon will be surrounded by 6 fluorine. 1, 2, 3, 4, 5, 6, and 2, drawing the lone pairs. Okay, so if you count all the electrons involved, there will be 48 of them. Okay, so the extra, that is, will have 48 electron. So the extra 2 electron are present as lone pairs on xenon. Okay, extra 2 electrons are present as lone pairs on xenon. Okay, so therefore XeF6 is best represented as so therefore the central atom xenon, that is this guy, has six bond pairs, one, two, three, four, five, six, and one lone pair. Therefore, and hence, the shape XCF6 takes is known as distorted octahedral geometry. Okay, this is known as the distorted octahedral geometry. Okay, and because of the presence of one lone pair, it disrupts the expected perfect octahedral geometry. Perfect octahedral should have been like this. Okay, now it's, you can say it's a disrupted octahedral geometry, and it's due to lone pair bond pair repulsions. So there will be repulsions. Okay, so therefore statement B, that is Q has perfect octahedral geometry, is incorrect. Cool. Now coming to statement C. Statement C says that Q, that is XCF6, act as a fluorinating agent. Okay, so first we have to understand what is a fluorinating agent. A fluorinating agent is a chemical substance used to introduce one or more fluorine atoms into a molecule. Okay, so it is used to introduce one or more molecule, sorry, one or more fluorine atoms into a molecule. Okay, so a fluorinating agent is a chemical substance used to introduce one or more fluorine atoms into a molecule, and all the three binary xenon fluorides, that is, XCF2, XCF4, and XCF6, all these three binary xenon fluorides, they act as very strong fluorinating agents. Okay, for example, XCF4 will react with platinum to give us xenon plus PtF4. So you can see it introduce fluorine into platinum. Similarly, XCF2 can react with NO to give us xenon plus NOF. So you can see it introduced fluorine into NO. Okay, so therefore, all these three guys are fluorinating agents. So therefore, Q is a correct statement. So it is a correct statement. Now coming to the last statement, which says that molecular structure of R is trigonal pyramidal. Okay, so obviously in our case R is XCO3. Okay, so the total valence electron in XCO3 is 8 from xenon plus 6 from oxygen into 3. So total there are 26 electrons, and therefore the electron dot structure will look something like this. So there is one lone pair. Okay, and xenon can expand its octet, so therefore these lone pairs are shifted to form a double bond. So ultimately XCO3 will look something like this: XC double bond O, double bond O, double bond O with a lone pair, and these are the lone pairs on oxygen. Sorry, I drew two extra. Yeah, so this is the electron dot structure of XCO3. Okay, and one important thing in determining the shape or geometry, we assume multiple bonds, that is double or triple, as single bonds. So you have to consider them as single bonds in calculating in determining the shape or geometry. So therefore xenon has, you can see, one, two, three bond pairs and one lone pair. Okay, so xenon has three bond pairs and one lone pair. So therefore, whenever we have three bond pairs and one lone pair, it has trigonal pyramidal shape. Okay, to draw that, so it will actually look like this with a lone pair. Okay. Okay, so therefore D, which says that molecular structure of R is trigonal pyramidal, is correct. It's a correct statement. Okay, so therefore the final answer is going to be, yeah, um, A. P has two lone pairs of electrons on the central atom. Correct. Q has a perfect octahedral geometry. Incorrect. Q can act as a fluorinating agent. Correct. The molecular structure of R is trigonal pyramidal. Correct. So therefore the final answer is A, C, and D. Okay. Thank you.